Hello, is 4 plus 3 always equals to 7? If you're talking about scalars, then yes, yeah. But if you're talking about vectors, then it depends. Take for example a 4 Newton and a 3 Newton force. So if they are in the same direction, then they add up to 7 Newtons. But if they are in opposite directions, then they actually add up to 1 Newton. And what about if they are if the 3 Newton is in the upward direction? Then actually 4 plus 3 gives us 5. How is that so? Now we have to talk about vector summation. Take for example, we are adding a 3 Newton upward force to a 4 Newton rightward force. So how do we do it? So first, we'll draw a 3 Newton upward force. So just draw a line that is 3 units long upward to represent the 3 Newton upward force. Then we draw the 4 Newton rightward force represented by a line that is 4 units long. So notice we have aligned them start N and then start N again. So what is the resultant force? We got to join the very starting point to the very end point. So this represents the resultant force. So how do I know this is 5? Well, it's because it turns out that this is a right angle here. So we are working with a right angled triangle, which makes our life very easy because we can do Pythagoras to obtain the magnitude of this line to be 5 units long. So that represents 5 Newtons. What about the direction? Well, we just have to solve for the angle here. So we can use trigo ratio because it's a right angled triangle. So we can obtain it to be 53.1 degrees. So you would describe the resultant force to be 5 Newtons in magnitude at the direction of 53.1 degrees east of north. Of course, the two vectors we are adding up need not always be perpendicular to each other. So let's try another one. So suppose there's a river whose current is flowing at a speed of 4 meters per second eastward. And then you're swimming in the river at the speed of 4 meters per second in the northeast direction relative to the water. So what would your resultant velocity be? So this is basically a vector summation problem. So first, let's draw the 4 meters per second eastward. So this is the speed of the current, yeah? And then we draw the 4 meters per second in the northeast direction. So this is the speed at which, the velocity at which you are swimming at, yeah, in the water. But the resultant is of course the summation of these two velocities. So remember, join the very start to the very end. So this represents your resultant velocity. So because of the water current, you end up with a speed that's larger than 4 meters per second. But how to calculate that speed? Because these two vectors happen to have the same magnitude, yeah? And actually it's going to make our life easier because we're actually staring at a rhombus with all sides equal. So if you look CC a bit, you realize that this angle here is 22.5 degrees. Because this big angle here is 45 degrees, and you know in a rhombus, this angle is bisected, right? So this is 22.5 degrees. So actually we don't even have to do a trigo ratio to find out the direction this time around. It's basically 22.5 degrees north of east. As for the magnitude, it's quite easy to calculate also because it's a rhombus, yeah? Because it's a rhombus, this is actually an isosceles triangle. So I can split it into two right-angled triangles. So let's look at this one here. So this is the hypotenuse side, 4 meters per second. That means that this side here is the adjacent side, so that would be 4 cosine 22.5 degrees. But I want the entire vector, right? This entire length. So that will be 2 times of 4 cosine 22.5 degrees. So turns out it's 7.4 meters per second. So I've shown you two examples where there's some shortcut. But of course, in general, you may not have such nice numbers. So let's suppose you are summing 4 meters per second eastward with a 5 meters per second in the northeast direction. The resultant is this vector here. There's no rhombus to talk about, there's no right-angled triangles to talk about, so you just have to calculate the magnitude and the direction by brute force, yeah? So how to calculate this vector's magnitude? Well, you can resort to the cosine rule, yeah? So this square is equals to 4 square plus 5 square minus 2 times 4 times 5 times this angle, which you know is 135 degrees. Yep, so you get the answer there. As for the direction, of course, we have to calculate this angle here. So what is the angle? So you can use sine rule, yeah? So you can say sine theta divided by 5 is equals to sine 135 degrees divided by 8.32. So you end up with that angle. So the direction would be, you can describe it as 25.1 degrees north of east. Alright, so that gives you a good idea of what vector summation is all about. See you, ta-ta!